Last time we used an example of test scores to find the quartiles, which we could then use to find the range and the interquartile range. This time there's 18 test scores. The median is the average of these two. Median can also be called quartile 2. The average of 15 and 18 is 16.5 points. The first quartile was 9. The third quartile, quartile 3, was 30. And the minimum was 0. And the maximum was 70. If you're unclear how I got those numbers, look back at the previous video. Today we're going to show, once we have these numbers, how we can use them to create a diagram that'll make it easier to understand what these data look like. And these are called box and whisker diagrams. We might also call them box and whisker plots, or for lazy, simply box plots. And you'll see where these names come from when I draw it. So once your data are in order, smallest to largest, what you want to do is make the range from 0, which in this case is our lowest number to our highest number, 70. And this is going to be like a number line. So 0, 10, 20, 30, 40, 50, 60, 70. I can label those. And then our plot is going to go on top of that. So we're actually going to start at the middle. Our median is going to be 16.5. That's maybe around here. That's our median. Our quartile 1 is 9, so just a bit less than 10. Our quartile 3 is 30 up here. And these three lines, quartile 1, the median, and quartile 3, are going to be the box part of our box and whisker plot. Half the data are in this range, going from quartile 1 to quartile 3. And then the rest of what I have to do, I find the lowest point, 0 in this case, and then I draw a line connecting that point to the left side of the box. So this is the lower whisker. It's lower because on the left side the numbers are lower. And then on the right side, I do the same thing but for the highest point, 70 up here, and I connect it here. And so this is the upper whisker. Now you might notice that these data are not symmetric. There's more down here, right? The first quartile and the median are pretty close together, and they're not too far away from the minimum. Compared to median to third quartile is pretty big, and third quartile to the very end of the whisker is extremely large. So this is one kind of box plot, or box and whisker plot, box and whisker diagram, whatever you want to call it. But we can actually make it a bit more informative, because if you recall from last time, this 70 here was an outlier. If you recall, an outlier is greater than the third quartile plus 1.5 times the interquartile range, or less than the first quartile minus 1.5 times the interquartile range. So the 70 is way outside here. We found in the last video that in order to be an outlier, you had to be either greater than 61.5 or less than negative 22.5. 70 is bigger than 61.5. You can also see that it's an outlier because this distance between the first quartile and the third quartile, the IQR, the interquartile range, starting at quartile 3, multiply this distance here by 1.5. My scale wasn't perfect, but this is roughly anything to the right of here would be an outlier because it's to the right of or greater than quartile 3 plus 1.5 times the interquartile range. So all this to say, this 70 here is in fact an outlier, and we can display that differently to make that more clear. So what I'm going to do is erase that line. The whisker doesn't go all the way there. I'm only going to draw the line up to the last value that wasn't an outlier. So 35 was the largest value that's not an outlier. So I'm just going to put a mark at 35 and then draw the whisker up to there. And now we see that from the smallest value that's not an outlier, in fact there's no outliers in the small direction, to the largest value that is not an outlier, that's a box and whisker plot. And then this outlier over here, sometimes we label this with an asterisk or a little star to show that it is an outlier. So the box and whisker diagram shows the interquartile range in the middle here. It shows the largest and smallest values that are not outliers, and it shows outliers. You may be wondering why we even use box and whisker diagrams. They are useful when you're comparing multiple things. So let's take an example from soccer. These are data found from all the over 18,000 players in FIFA 20, looking at height in centimeters for different positions. So in this case, the box and whisker plot is sort of sideways. Instead of large being to the right, large is going up, right? 200 centimeters here, that's 2 meters, down to 160, and a bit above and below. Looking at this box and whisker plot, it's very easy to compare once you get some practice with it to see which positions are the tallest and which are the shortest. By the way, in this plot, instead of using asterisks, they use these little diamonds there. That means outliers in this case. So we can look and see, well, the shortest player of anybody is a midfielder. That's an outlier in that direction. There's a forward who's pretty short. We can see the outliers. There's a lot of outliers down here and a few elsewhere. We can see that the tallest one's the goalkeeper. But we get a lot more information than this. We can see the medians. So a typical midfielder is around 178 centimeters. A typical goalkeeper is around 188. And then the defenders and the forwards are maybe 185. So that's interesting. We can compare what the medians are. From that, it's clear that goalkeepers tend to be the highest. But we can also do even more than that. With midfielders, not only are they on average shorter than the rest, but there's a pretty big range in how tall they are. Taking out outliers, it still ranges from like 162 to 195, whereas with goalkeepers, it only ranges from around 178 to maybe 201. So midfielders are shorter, there's a greater variation in how tall they are, and also we can compare these two by noticing that this right here, this 182 for midfielders, is quartile 3 for midfielders. That means that 75% of midfielders are 182 centimeters or less. Okay, so that's quartile 3. We have the first 25% down here, the next 25% up to the median here, the next 25% here, and then the last 25%, the tallest 25% up here. So 75% of midfielders are 182 centimeters or less. With goalkeepers, this value right here is the first quartile, it's quartile 1. So that shows that 75% of goalkeepers that's around 187 centimeters or more. Right, so only 25% of goalkeepers are in this lower region right here. The next 25% up to median in this range, next 25% up to maybe 191, and then the last 25% up here. So if we look at a pretty tall midfielder, right, somebody who's taller than 75% of midfielders, they're probably still shorter than a short goalkeeper. So anyway, this is just an example to show how if we have multiple box and whisker plots comparing the same variable, they're all comparing height, but across different categories, we can visually see how those things compare.